This is Mr. Sitta. I'm going over Chapter 19, and Chapter 19 is acids and bases, and so I'm going to go over some calculations for acids and bases. Um, all right, here we go. The pH scale. If I have the autoionization of water, okay, that would be one water molecule hitting another water molecule. And in Bronsted-Lowry, uh, the acid would donate an H plus to the base. The base accepts the H plus, the acid donates it. So if I looked at this water and said, oh, it's getting an H plus from the other water, this would become H3O. The base, when it reacts as an acid and a base, this would become your conjugate acid, and this one would lose an H, so it would be OH negative 1, and that would become your conjugate base. Now if I drew this as a K is always the products over the reactants, and this is called an equilibrium expression. You multiply the concentration of H3O times the concentration of OH. Now in this case we don't put the water underneath it because water is considered to be a constant. When all this goes on, these are constants. This is called the KW of water. Okay, the KW of water is always 1 times 10 to the negative 14. Now, if I multiply this one by that one, okay, I know that this would be like x squared. They would equal each other. If I said that's equal 1 times 10 to the negative 14, if I'm going to solve for the x, I'm going to take the square root. My wife doesn't know that I'm recording. So the square root of 1 times 10 to the negative 14th is 1 times 10 to the negative 7th molar. So in neutral water, H3O in neutral water is equal to 0.1234567 molar. The hydroxide is equal to 0.1234567 molar. They equal to each other, and they're very small amounts. So there's a small amount of acid and an equally small amount of base in neutral water. Because this K, this is called the ionization constant. And because if this is a constant, as one goes up, the other would have to come down. So these two become inversely proportional. As the base goes up, the acid comes down. And that's where we start off with our pH scale. Now, standard state conditions. Is designated by a little 0. It's not STP, and don't confuse it with STP. There's only one difference between STP. The pressure is still 1 atm. The temperature is not 0. The temperature is 25 degrees Celsius, which equals 298 K. And that's what's different about standard state conditions. Okay? And then molarity, they assume that the most strongest you can be is just 1 molar. So they limit out the 1 molar. Okay? And now that sets you up with the pH scale, but the thing is, you're dealing in very small numbers. Okay? So here's what your pH scale ends up looking like. And I want you guys to be able to calculate pHs. okay, from your concentration of H3O and hydroxide. Okay. Now, let's see, 1, 2, 3, 4, 5, 6, 7. I'll go with 8. If I start right here and I say this is neutral water, then the concentration of H3O is 1 times 10 to the negative 7th molar. The concentration of OH would be equal 1 times 10 to the negative 7th molar. So if I go up on this scale, this is going to be increasingly acid. And at the top, we'll have the most acidic, the strongest acid. Okay? So as I go increasing strength, this number will go down. 1 times 10 to the negative 6 is stronger than 1 times 10 to the negative 7th. That's a bigger number. Well, the 7 times the 7, 10 to the 7th times 10 to the 7th is 10 to the negative 14th. Well, as this one goes up, this one goes down to negative 8. 10 to the negative 6 times 10 to the negative 8 is still 10 to the negative 14th. Okay, we keep going. 1 times 10 to the negative 5th. 1 times 10 to the negative 4th. 1 times 10 to the negative 3rd. 1 times 10 to the negative 2nd. 1 times 10 to the negative 1 molar. And the strongest you can be is 1 times 10 to the 0. 10 to the 0 equals 1. Well, here's where you're 1 molar. So that's the most acidic you can be is 1 molar, 1 times 10 to the 0. Okay. Follow it with the OH. As this scale was going down, this scale is going up. So 1 times 10 to the negative 9th. 1 times 10 to the negative 10th. 1 times 10 to the negative 11th. 1 times 10 to the negative 12th. 1 times 10 to the negative 13th. And in theory, we say the smallest concentration will be negative 14. 10 to the 0 times 10 to the negative 14 equals 10 to the negative 14th. That's that same kW that you have to maintain anywhere. 10 to the negative 2nd times 10 to the negative 12th equals 10 to the negative 14th. Negative 4th times negative 10th equals negative 14th. So that's your acid scale now. Going down, I'm going to say now we're increasingly basic. So now I'm going to go down with the acid. 1 times 10 to the negative 8th, 1 times 10 to the negative 9th, 1 times 10 to the negative 10th, 1 times 10 to the negative 11th, 1 times 10 to the negative 12th, 1 times 10 to the negative 13th, and the lowest concentration of acid you can get is negative 14. Now, this is the most basic. Well, if I multiply that, I would have to multiply it by 1 times 10 to the 0 to get 1 times 10 to the negative 14th, the kW. So 1 times 10 to the 0 is 1 molar hydroxide. Up here, this would be 1 molar H+. Okay? And now, going down, 1 times 10 to the negative 6, the OH, the base, would now become increasingly strong. So in a basic solution, here's the typical test question you're going to get. If your solution's basic, the OH is greater than the H3O. If your solution is acidic, the H3O is greater than the OH. If your solution is neutral, well, I know what they are. They're both equal to 1 times 10 to the negative 7th in a neutral solution. All those questions can be on your test. Okay. Increasing strength, negative 5th, negative 4th, negative 3rd, negative 2nd, and negative 1. Okay. Now, dealing with these exponents, what we did is we come up with an easier way to classify acids. Okay. And to classify acids, we're going to use the definition of an acid on the this is the pH scale. So pH, by definition, is your negative log of your H plus, which is the same as H3O. I might mention that hydronium is equal to H plus. H plus was always in theory. If you're in a glass of water and you have, 1 times 10 to the 23rd water molecules, if I put a H plus in there, that's going to bond right to the extra pair of electrons on water, and it's going to create H3O. So really in water, acid is seen as H3O. In theory, we just say H plus, but in reality, it bonds to water to become H3O. All right, so on my pH scale, I can also say that pH3O would equal negative log of H3O. Okay, for the bases, POH, there is also something called a POH. You've heard of pH, you probably haven't heard of POH. POH is the same thing, is a negative log of hydroxide. Okay, and these are the equations that you need to know. Okay, I'll give you these equations on the test. All you got to do is plug them in. What a log scale does is it takes scientific notation. The log is your number, is your exponent of the 10. It's the log is on base 10 is your exponent. So if I ask you what's the pH of 1 times 10 to the negative 4th, on my calculator I plug in, okay, negative, there's your negative button, log is right under here, and then I'll put in 1, and if I want to put in the exponent, right here the EE button, and you'll want to use the EE button just like we did on quantum, okay, and then negative 4th, and your answer is 4. Now, the front number is always my number of zeros. So if I said, like over here, 0.123 4. That's your number of zeros. Significant figures. The log of 1 is a 0, so whenever you do pHs, and this is unique to pHs, your front number is not significant. It's the numbers after the decimal that are significant. And me putting a 0.0 there means I have a 1 in the front. That's 1 sig fig. Well, if I just go ahead with this, if I take the negative log of that, it becomes 3.0, 2.0, it's your exponent, 1.0, and the highest, 0.0. Okay, 0.0 is your highest pH, that's your most H3O. As this number goes down, you're actually getting more hydrogen. Okay, going back the other way, 5.0, 6.0, 7.0 is neutral, 8.0, 9.0, 10.0, 11.0, 12.0, 13.0, and 14.0. So your pH scale goes from 0, which is the most acidic, down to 14, which is the most basic. And neutral would be right in between at 7. Okay, that question will be on your test. What's the pH scale? 0 to 14. 7 to 0 is acidic. 7 up to 14 is basic. 7 is neutral. Okay. There is also a P. This will go as my pH, which would be the same thing as pH3O. My POH would be just the opposite. Exponent is 14. I'll put a 0.0 at the end. 13, 12, 11, 10, 9, 8, 7 is neutral, 6, 5, 4. Now this would be basic, 3, but it's not pH, this is POH. 2, 1, down to 0 would be the most basic. Okay, now off this, I get a couple equations. The equations I know that if I take the concentration of H3O and multiply it by OH, if I know H3O, I can always find OH, because together, when you multiply them, they always equal to the KW 10 times 10 to the negative 14th. That's my KW. Okay? So I know that equation. So if I know H3O, I know OH. If I know OH, I know H3O. You can find all these things. If I know H3O, then I can find my pH. If I know OH, then I can find my POH. And if you look at this, if you add them, 0 plus 14 is 14, 4 plus 10 is 14, 9 plus 5 is 14, 7 plus 7 is 14, 11 plus 3 is 14. You find out that pH plus POH then always add up to 14. And if I look at that 14, that's actually the negative log of my KW, which I can just call the PK. We won't really get into that. But what I've done is I've taken the negative log of these two to become pH and POH. Multiplying with logs becomes plus. And I would also take the negative log of the KW, which is my PKW. Okay. Now, if I have concentration of, if I have the pH, how do I find the concentration of H? Well, I'm going to take this equation. Let me solve that in the next page. Okay. If I know that pH equals negative log of H, then I'm going to take the negative and I'm going to solve for the H plus. Now, how do I solve for that? How do I get rid of a log? You get rid of a log with an anti-log, which is right here on your calculator. There's your button for log. Anti-log is right above it in blue, 10 to the x. So if I had a number like, well, let's do it. If I want to solve for this, I'm going to take 10 to the log of H plus, and I'm going to take 10 to the negative pH. Well, these two cancel each other out, and that just equals your H plus. So your equation becomes H plus concentration equals 10 to the negative pH. So there, given the H plus, I can find, given the pH, I can find your H plus. On the same aspect, if I do it for OH, the concentration of OH is 10 to the negative POH. Okay. All right. The next, I'm going to do another video that's going to show you how to plug in numbers for these and how to solve everything. And that'll be following.